It was so easy, and then
Okay, I'm Donovan Wixom, and I'm doing problem 4. So, part A says to determine the allele frequency of R2 and R3 alleles. So up here, I've done a little bit of work. Basically, I found the p squared, the 2pq, and q squared just by taking the numbers given over the total. So for p squared, it's 135 over 190. For 2pq, it's 44 over 190, and for q squared, it's 11 over. For R2, that's just going to be equal to p. And since we have p squared up there, we just take the square root of this number, which gives us 0.842927. Or obviously, if it's a percent, you move the decimal over 2 and put a percent. And you're just going to do the same for R3. That's an R, I promise. Except it's Q. So you take the square root of this one, which gives us 0.240163. And that's the allele frequencies. And I'm going to get rid of them. Okay, part B, we're supposed to find a chi-square value for these. So to start, we need to find our expected, what we're going to get. And we're going to use these numbers to find our expected. And we're basically just going to multiply. So this is the expected for homozygous R2. That's the ratio we expect. So we just times it by our total population. We're going to do that for all of them, actually. Times it by the 190. So R2 homozygous, we expect to get about 134.99994 individuals. R2, R3, we expect to get around 77.071293. And then homozygous R3, we expect to get about 10.999. Those are 9s. So then, once we have our expected, we just do a normal chi-squared test, plugging in what we got, 135 minus our expected, 99 over 134 points. I know I'm in the way, but it's so hard to write sideways. Plus, what do we get? 44 minus 77.0712. 77.0712. I'm running out of board space. 11 minus 10.9 repeating over 10.9 repeating. So for these two, you're going to get really small numbers. For this one, I got 2.6 repeating times 10 to the negative 11th. It was super tiny. And then for this one, I got another small number. It was like 0. I think there was 8 zeros. I'm not going to count them. A ton of zeros, and then 9. This one is the one that's really off. You can tell 44 is not close to 77. I got about 14.190892. And when you add it all up, these are so small that when I rounded, it was still basically the same. So that's our chi-squared value. And that is big enough, if you check the table, that we reject our null hypothesis, which means that this population is not in equilibrium. There is some sort of evolution occurring.